Trigonometry is the study of triangles, and so here we're looking at the study of right triangles. And so right triangles have these trigonometric functions. There are 6 of them that are associated with them, and they're really just the ratios of sides of a right triangle. Now perhaps the first 3 here are familiar to us from our geometry days. So sine of an angle is the measure of the side opposite over the hypotenuse. So the hypotenuse is the longest side of a right triangle. It's the one that's across from the 90-degree angle. And so when we talk about the opposite, so from this angle right here, the side across from that angle is the one that's opposite. The one that is next to it but isn't the hypotenuse is the side that's adjacent. So we get the ratio of the opposite side to the hypotenuse. And so the bigger the angle, the bigger this opposite side is going to be. So the bigger the sine value is going to be. Whereas the smaller the angle, the smaller that opposite side is going to be, so the smaller that ratio is going to be. So sine is defined as opposite over hypotenuse. Cosine is defined as being adjacent over hypotenuse. So now we're taking the side next to the angle, dividing it by the longest side. And then the tangent takes the ratio of the opposite and the adjacent. So now we're taking the opposite, dividing it by the adjacent to get a ratio. And then we have these other 3 trigonometric ratios that are just the reciprocals of the originals. And for maximum confusion purposes, cosecant doesn't go together with sine, but it goes, or cosine, it goes with sine. So you can see that these are reciprocals of each other. Opposite over hypotenuse for sine, hypotenuse over opposite for cosecant. Cosine and secant are reciprocals of each other. So we've got adjacent over hypotenuse and hypotenuse over adjacent. So we're just flipping the ratio is all we're doing. And then tangent and cotangent, at least those 2 go together. And so we've got opposite over adjacent for tangent, adjacent over opposite. And so when we're trying to write what the sine or cosine or secant or cotangent of an angle from a triangle like this is, we're just making sure that we correctly identify which is the opposite, which is the adjacent, and which is the hypotenuse. The hypotenuse will always be the side across from the 90-degree angle, but the opposite and the adjacent sides can vary depending on which angle's perspective we're looking at. So as we go through this example, for the angle A, so that's this angle right here, the side opposite of angle A is going to be this 15, and then the side adjacent to angle A is going to be 8. So I'm going to use those measurements along with the hypotenuse being 17 to get all of these ratios. So the sine of angle A, again referring to what's defined up here, sine of angle A is opposite over hypotenuse, so I've got 15 over 17. Cosine is adjacent over hypotenuse, so the adjacent side in this diagram is 8. The hypotenuse remains 17, so we get 8/17. And then for tangent, we've got opposite over adjacent, so 15 over 8. And then we're just going to take reciprocals of those for the next 3. So CSE is cosecant, so that's the reciprocal of sine. So we're going to have 17 over 15, hypotenuse over opposite. Secant is the reciprocal of cosine, so that's going to be hypotenuse over adjacent. And then finally for cotangent, that's the reciprocal of tangent. So instead of opposite over adjacent, we want adjacent over opposite. So we can just flip the answer that's above to 8 over 15. For the B angle, the hypotenuse is still going to be 17. That's not going to change. What is going to change, though, is our opposite and our adjacent. Now when we look for the side that's opposite of angle B, it's no longer 15, it's 8. Here's our side opposite of angle B. And then the side adjacent to it is the one right next to it. That's the 15 right here. So when we start to find the sine and cosine and all the other trigonometric ratios for angle B, we're going to see a lot of the same answers, but they're just going to be flipped around. So for example, sine of angle B is going to be opposite over hypotenuse, so 8 over 17. So that ends up being the same answer as the cosine of angle A. They have the same hypotenuse, but now the opposite and the adjacent sides have flipped. Likewise, cosine of B is now going to be adjacent over hypotenuse, with the adjacent being 15 and the hypotenuse is 17. And then for our tangent, opposite over adjacent, we're just going to go 8 over 15 instead of 15 over 8 like we had for tangent of angle A. And then again, for the cosecant, secant, and cotangent of B, it's just going to be the reciprocals of all these values. So I can just go ahead and jump straight to that. Cosecant's the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. Given some information about one trigonometric ratio for an angle, we can use it to find the other trigonometric ratios. And the way we're going to do that is by drawing a triangle based off of this information. So I'm not going to bother to try to draw it to scale, but I am going to draw a right triangle with my angle theta, the one that's being discussed here, in the lower left-hand corner there. And so now I'm told that the sine of this angle is going to be 12/13. So remember that sine is opposite over hypotenuse. So that means my opposite side to this angle, the one over here, needs to be 12. And then the hypotenuse, the longest side, the one across from the 90-degree angle, has to be 13. And so then to figure out this length right here, we can call it A, we need to use the Pythagorean Theorem to figure that out. And so we may recognize this as being part of a Pythagorean triple, where all the values will be whole numbers. But if not, we've got A squared plus 12 squared equals 13 squared. So that means we have A squared plus 144 equals 13 squared is 169. If we then subtract 169 from both sides, or 144 from both sides, we get 25. And so then if we take the square root of both sides, we get that opposite side, or that adjacent side equals 5. A equals 5. And so now that I have this picture with 12 as the opposite side, 5 as the adjacent side, and 13 as the hypotenuse, I can write the ratios for all of these other trigonometric functions. So cosine of theta, if we refer back to the top of the notes, cosine of theta is adjacent over hypotenuse, so that's going to be 5 over 13. Tangent is opposite over adjacent, so in this case that's going to be 12 over 5. And then cosecant, secant, and cotangent are the reciprocals of sine, cosine, and tangent. So cosecant is the reciprocal of sine, so sine is 12/13. So cosecant is going to be 13/12. Secant is the reciprocal of cosine, so 5/13 flips to 13/5. And then cotangent is the reciprocal of tangent, so 12/5 flips to 5/12. In the second example, we're given the secant of theta is 3/2. So if we look back to our list of ratios for the various trigonometric functions, we can see that secant is the reciprocal of cosine, which is going to be hypotenuse over adjacent. So I'm going to draw a triangle just like the one that I drew over here. So I've got a right triangle with theta in the lower left-hand corner, right angle over here, and then I'm going to label the sides. The hypotenuse is going to be 3, and then the adjacent side, so the side next to our angle theta, is going to be 2. So once again, I'm going to have to use a little Pythagorean theorem to figure out what this opposite side is. We can call it A. So that means I've got A squared plus 2 squared equals 3 squared, or A squared plus 2 squared is 4, 3 squared is 9. So if we subtract 4 from both sides, I get A squared equals 5. And then if I take the square root of both sides, I get A equals root 5. Or in other words, I've got an adjacent side of 2. I've got A is equal to the square root of 5. And then my hypotenuse is 3. And so those are the measurements that I'm going to use to complete the rest of these ratios. For the sine of theta, I'm going to take opposite over hypotenuse. So my opposite is over here. My adjacent is this guy here. So opposite over hypotenuse is going to be root 5 over 3. For cosine, that's just going to be the reciprocal of the given information, adjacent over hypotenuse. That's going to be 2 over 3. And then tangent is going to be opposite over adjacent. So that's going to be root 5 over 2. And then the last two I have are cosecant. So cosecant is the reciprocal of sine. Well, if the sine was root 5 over 3, then I need to flip that into 3 over root 5. But I can't leave a root in the denominator, so I need to multiply the top and bottom by root 5 here. So I'm going to get 3 root 5 over 5. And then for cotangent, I'm just going to flip my tangent answer. So I had root 5 over 2, so now I've got 2 over root 5. But I have to do the same sort of thing that I just did on the cosecant. So I'm going to multiply the top and bottom by root 5. And so I get 2 root 5 over 5.